Welcome to my YouTube and Facebook channel. In this video, we will discuss about Triboelectric Nanogenerator. New technology successfully harvests electricity from raindrops. Tsinghua University researchers have made significant progress in harnessing electricity from raindrops using a technology called droplet-based Triboelectric Nanogenerator. D-TENG. Similar to hydropower, where moving water generates electricity, raindrop energy can serve as a sustainable and clean source of power. However, scaling up this technology has been challenging until now. The D-TENG device employs liquid, solid contact electrification to capture and convert energy from falling raindrops, as well as from waves and other liquid, solid interactions. The main obstacle in implementing multiple D-TENG panels together lies in unintended coupling capacitance between the upper and lower electrodes, resulting in reduced power output. To overcome this limitation, researchers at Tsinghua University have proposed a novel solution, modeling D-TENG panels after solar panel arrays. This approach involves using bridge array generators with array lower electrodes to minimize the impact of unintended capacitance. When a raindrop falls on the D-TENG panel surface, known as the FEP surface, a process called triboelectrification occurs, generating and storing energy from the rain. The FEP surface becomes negatively charged, while the droplet becomes positively charged. This charge accumulation continues until saturation, where the dissipation rate of the surface charge balances the charge generated by each droplet impact. The results, published in the journal iEnergy on June 29, showcase the success of the bridge array generators. Comparing conventional D-TENGs with the bridge array generators, the latter exhibited nearly 5 times higher peak power output, reaching 200 watts per square meter. This significant improvement demonstrates the advantages of large-scale raindrop energy harvesting using bridge array generators. Professor Zhong Lai from Tsinghua Shenzhen International Graduate School emphasized the importance of simultaneous utilization of multiple D-TENGs to power megawatt-level electrical equipment. By adopting the bridge array generator design, the researchers have paved the way for efficient and practical large-area raindrop energy harvesting. This breakthrough in raindrop energy collection opens up new possibilities for sustainable energy sources and contributes to the global efforts towards a greener and cleaner future. Reference: Rational TENG Arrays is a panel for harvesting large-scale raindrop energy by Zhongli, Bin Kao, Zonghao Zhang, Liming Wang, Zhong Lang, and Zonglin Wang. eEnergy, June 29, 2023. Dewey, 10.23919. AN 2020. 23,900. Funding for this research was provided by the National Natural Science Foundation of China. Grant, no. 52,007,095. Other contributors to the study include Bin Kao and Liming Wang from Tsinghua Shenzhen International Graduate School, Zonghao Zhang from China Electric Power Research Institute, and Zonglin Wang from Beijing Institute of Nanoenergy and Nanosystems at the Chinese Academy. Thanks for watching. If you like video, please subscribe, give feedback and comments, and share with others. Keep watching my videos.